All right, here we have a binomial times a binomial, and there were two methods that we did to solve this problem here. So I'm going to show the two methods as a review, and then we're going to do a binomial times a trinomial. So one method was called the lobster claw, and then the other method was the box method. I'm going to start with the lobster claw here. I'm going to copy the problem again. And I call it the lobster claw. It's really just distributing, right? Where I would draw the arrows from one term to both of the other terms here. I would do that for the first term here. And then I would draw the arrows again. This time I'm going to draw it below, right? I would say it kind of looks like a lobster claw that way, right? So 6v times v, you get a 6v squared. 6v times the minus 3, you get a minus 18v. This is a minus 4 times the v. And then a minus times minus 4 here times the minus 3 here, that's going to give me a positive 12. You'll notice I do get like terms here. So I would have to combine those like terms like so here. So that's the lobster claw method. The box method is where I would draw a 2x2 box like so here, right? And because it's a binomial times a binomial, each set of parentheses here has two terms, right? So for the first binomial, I would take the 6v minus 4, and I would label the side length here, right, with those two terms. For the second binomial, I would take the v minus 3 and label the side length there with those two terms, right? And then in each box, I'm multiplying. So this would be a 6v squared, right? This would be a minus 4v. Here we get a minus 18v. And negative 4 times negative 3, positive 12. Right? You'll notice that all of the terms I have in this box were the same as all of the terms I had here. So we're doing the same thing, it's just set up differently. And I would still need to combine like terms, so I get the same answer, right? Negative 18v minus the 4v would be a minus 22v. So no matter which method I do, I get the same answer there, right? So those are the two methods that we went over for multiplying a binomial. Now, I want to show you a binomial times a trinomial, right? And I'll put this on the board here. All right. Cross out this one. All right, so binomial times a trinomial. We're still going to use the two methods that we've learned, right? So to start with this one, I'm going to use the lobster claw method. I'm going to distribute. The way I like to think of it, it's almost like a mutated lobster claw. I'm going to take this first term and draw my arrows to all three terms in the trinomial. It's kind of like this mutated lobster claw we got here, right? Second term, I'm going to draw my arrows underneath to all three terms in the trinomial there, right? This kind of giant lobster claw we have. So 5v times 5v squared, you would get a 25v cubed, right? 5v times 6v, you would get a 30v squared. 5v times 2 plus 10v. Now I'm going to do with the second term here. 6 times 5v squared, 30v squared. 6 times 6v, 36v. 6 times 2 is 12. So longer expression here, right? Which makes sense because we have more terms. And you would combine those like terms, right? Nothing to combine the cube term with. I do have two 30v squares. That would give me a 60v squared. 10v plus 36v would be 46v plus 12. right? So that's the lobster claw method. Let's do the same problem now with the box method, right? I still have this binomial here, right? So I still have like 5b and 6. But now, when I draw my box, it's almost going to be more like a rectangle here, right? Because I have 3 terms, right? It was 5b squared, 6b, and 2. So I'm doing the same thing where I'm multiplying the side lengths for each box here. So this is set up differently than the lobster claw method, but still multiplying each of the terms, right? So this would be a 25b squared, b cubed, a 30b squared, and a 10b. I do those. And this would be a 30b squared, 36b, and 12. So you'll notice I get the same terms as I did here, right? And I would have to combine those terms. We just have the 125b cubed, right? I would get the 60b squared, the 46b, and the 12. So you see, once again, I get the same answer, just kind of set up differently. So you'll have to multiply a binomial by a trinomial, and you can kind of choose the method that works best for you there. I'll leave that up on the board. You can pause it if you need to write it down. Thanks for watching, guys.